Okay, here's the solution to homework set number 4 for ECE 341. This homework deals with binomial and uniform distributions. The first problem is a binomial distribution where I have a probability of getting a heads of 0.6. And kind of what that looks like, if you do the PDF, I've got a 40% chance of getting a 0, 60% chance of getting a 1, or heads. Problem 1 is, what's the probability of tossing the coin 8 times and getting 6 heads? Well, there's a couple ways to do that. If you use the formula, it'd be 8 coins choose 6. Probability of a heads is 0.6. I got 6 of them. Probability of a tails 0.4. I got 2 of them. Multiply it out, I get 0.209. Problem 2 says calculate the PDF of flipping the coin 8 times. And again, one way is to plug in n for 0 through 8 into this equation. A second way is to use convolution. So for a single coin toss, I have 0.4 and 0.6, chance of 0 and 1 head. Convolve it, here's a chance of 0, 1, and 2 heads. Convolve 2 coin flips twice, I get 4 coin flips. So there's a chance of 0, 1, 2, 3, and 4 heads. And do 4 and 4, I get 0, 1, 2, 3, 4, 5, 6, 7, 8. And notice that this is the same as problem number 1. The second way of doing it. Problem 3 is the National Oceanic and Atmospheric Administration's been keeping records of world temperatures for the past 142 years. 19 of the last 20 years have been in the 20 hottest on record. What's the probability that's due to chance? Well, the probability of any given year being on one of the 20 hottest on record is 20 in 142. So this is a binomial distribution. Here's the probability of a heads. Here's a probability of a tails, or it's not in the top 120, or top 20. Probability of 19 of the last 20 would be 20, choose 19, times p to the 19th, q to the 1. Multiply it out, and that's what you get. So if you're a Senator Cruz fan, he is correct. This could be due to chance. It's not proof of global warming. The probabilities due to chance is 0.000000000000001, but there is a chance. So Ted Cruz might be right. Not terribly likely, but could be right. Problem 4. Assume you have a fair 6-sided die. The z-transform of that would just be this. And you kind of get that for a 6-sided die, I'll have the numbers 1 through 6 coming up each with equal likelihood, or 1 and 6. So it's just a delta function at the integers. Each one has a height of 1, 6. And the z-transform of that would be 1 plus 1 over z times the 6th plus 1 over z squared times the 6th plus 1 over z cubed to the 6th and so on. Put over common denominator, and that's what you get. Now suppose I roll a level 8 fireball, which is rolling 8 6-sided dice. Determine the PDF, the mean, and the standard deviation. Well, the PDF, this is probably easiest to do using convolution. Take a single 6-sided die. I'm never going to get a 0. And I've got a 1 in 6 chance of getting the numbers 1, 2, 3, 4, 5, 6. You could keep on going. Those would be zeros, but not necessary. If I convolve a 6-sided die with a 6-sided die, I get 2 6-sided dice. 2 and 2 gives you 4 6-sided dice, 8 6-sided dice. And there's my answer. And just to display it, let's do a bar graph. So here's the probability of rolling each number for 8 6-sided die. So that's what the distribution looks like for a level 8 fireball. And kind of notice, this is a bell-shaped curve. That shape we keep seeing over and over again, that's called a normal distribution. Probably one of the most important distributions in all statistics. We'll be getting to that later. The mean then, a couple ways to do that. I have the mean for single six-sided die is 3.5. For 8 dice, it'll just be 8 times that. The variance for a six-sided die is 2.91. For 8 dice, it's 8 times that. And notice it's the variance that scales, not the standard deviation. Take the square root, I get the standard deviation, 4.8. That's one way. Second way is the definition. The mean, by definition, is the value times the probability. Add it all up, the average is 28, same as we did before. The variance is the distance from the mean squared times the probability. Add it all up, I get 23.3, which is the same thing we calculated for the variance this way. So either way works. Problem 5. Suppose I roll a level 15 fireball, being a very high level magic user. What's the PDF for the damage that I expect to do? And the mean and the standard deviation. Again, I'm going to use MATLAB and use convolution. In this case, take a six-sided die, convolve it once, I get 2 six-sided dice, 4, 6, 8. 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15. So there's the PDF for a level 15 fireball. Plotting as a bar graph, again, it looks like that nice bell-shaped curve, normal distribution. I'll do damage between 30 and 80 damage. The mean is 15 times the mean of a single die, 52.5. The variance is 15 times the variance of a single six-sided die, 43. Take the square root, I get 6.6. So the mean is the average. The variance is the measure of the spread. The wider it is, the bigger the variance, or the bigger the standard deviation. And kind of a rule of thumb. If you take 3 standard deviations, that's roughly the spread. So this will have a spread of about 20. So, yeah, about there. You can also use that definition to find the same answers. The mean is the probability times the value, gives you 52.5. The variance is the distance to the mean squared times the probability, 43.75. Those match up. So, again, either way works. So that's homework set number 4 for ECE 341.